My name is Diana Alonso. I'm the Mechanical Engineering student here. And our project is a second vehicle safety alert system. And we are team engineering. My teammate is Siddhartha Barai, and he is the telecommunications engineer. He worked on microcontroller and communication systems design. And then Eric Perez and Albert Zulu are electrical engineers, and they worked on the sensors of this design. And I worked on the biological research. Our project has the basic goal of reducing the number of deaths due to hypothermia within a motor vehicle. These deaths occur not just in children, which are what you most popularly hear about on the news, but also it can happen with the elderly, the disabled, as well as pets that are left in the car. So thousands of individuals, pets and humans die every year due to this. What we have designed after doing extensive research is a device that uses 3 types of means to determine there is light in the car, coupled with a temperature sensor that would indicate when the temperature has reached an unsafe level. After doing research into both cats, dogs, and infants, we were able to determine appropriate carbon dioxide levels that we would see a rise in a 4-door passenger vehicle. So we will be using a CO2 sensor in order to determine a rise in CO2 levels, but we'll also be using motion detectors and then infrared sensors. And infrared sensors would hopefully, we're going to test to see how effective they would be at determining if there's an animal that is left in a carrier, such as a cat carrier that might have been left on the floor of the vehicle, where we may not be able to get the CO2 concentrations to disperse appropriately in a timely fashion. So we'll be coupling these sensors with the temperature sensor. If any one of these 3 sensors shows that there is light in the car and the temperature has reached above 95 degrees Fahrenheit, a signal will be sent out to alert the caregiver. We chose to use a microcontroller, the Arduino Mega 2560R3, and we're going to use that to evaluate the sensor data and to send a signal to a GSM shield that will then send a text message to the caregiver. The GSM shield is also Arduino, and it is able to work over both AT&T and T-Mobile networks, and we will be testing it over the AT&T network sensor. So we have our components. We have a test plan that complies with the UT Dallas policies, and next semester we will be implementing that test plan. We'll be also then determining the power source, whether to integrate the system into the vehicle or whether to use an external power source such as battery or renewable energy. And we'll also be designing packaging that will allow for easy installation into the vehicles. Are there any questions?
So how are you going to detect that somebody's actually in the car or not moving?
That's where the CO2 sensor will be able to be utilized because they're still going to be expelling carbon dioxide. So we know that with an infant, if their average newborn infant has approximately a 13 milliliter tidal volume per minute, and that they have 3% CO2 expiration rate on there. And so we were able to determine that in a Chevy Impala, which is one of the top 3 most popular 4-door sedans in America, that they would have a 4 parts per million rise every minute of CO2. So even if they're not actively moving to alert one of the other sensors, the CO2 within 15 minutes would be able to show an appropriate rise.
But wouldn't you not see that if the windows were cracked? Because I guess sometimes, a lot of times, the windows are slightly cracked, but it still gets really hot in the car, and like, something happens to the baby. So I guess, have you guys done the calculations for even with the windows cracked, the CO2 would still be detectable?
We've not done the calculations with the windows cracked, but we did address that issue by the infrared and the motion, because the infrared would still sense that there was a child or another living being in the vehicle, even if they were not moving, because they would be having the infrared emissions on that. We're also, part of our test plan is to determine the best location for these sensors. So we will be testing it with the windows cracked open, as well as having them completely closed, because there may be a location in the vehicle that would be able to help minimize the loss of the CO2 with the windows being just a little bit cracked open.
And is power a concern? I guess you're gonna run this off the battery, but how much does the H.E.L.M.I.T platform consume in terms of power, right? It's gotta be running the whole time, isn't it?
Yes, it does need to be running the whole time. We will be exploring that much further next semester. We know that Adreno has a range that would allow for tapping into the 12 volt of the car battery, but we are also going to look at other means for having it powered next semester, because that is one of the concerns, is to make sure that it doesn't use up all the juice in the car.
Have you, particularly on your CO2 sensor, have you investigated at all what the issues might be with false positives? For instance, if you've got kids, the odds of you having food decomposing in between the seats are relatively high, speaking from experience, and I would assume that there will be some CO2 or stuff that could potentially be falsely detected with CO2.
We've not actually addressed the food decomposition.
Okay.
That is actually a good concern to have brought to our attention. What we do expect, though, is that the decomposition of the food particles would not be at the same level of increase, and that is something that we could definitely add to our test plan to test that out.
One last question.
Have you considered the infrared detector and how you're going to be able to detect someone whose body temperature is 97 Fahrenheit compared to something in the 90s? Generally.
The lower body temperatures, we haven't. Your average newborn infant body temperature is 99.5 as a general core temperature, so of course the extremities are going to be a little bit lower, but they also have a much smaller body surface. And then your average temperature for cats and dogs are both over 100 degrees, and that's their average temperature. So those are our primary, although we can use this device with elderly and disabled, and they may have a lower core temperature. However, even with the core temperature, the reading of a core temperature, if they're 97 degrees and that's their core temperature, then they have, that's actually their solid core temperature. Then there's some other issues involved. That is something that we're hoping that it would be most likely an adult, and they would have a much higher CO2 rise level and more likely to show a greater motion that was set off the motion detector.
All right, I think we can thank you.